हेलो फ्रेंड्स, वेलकम बैक टू माय चैनल। तो आज हम लोग बात करने वाले हैं द ओशियनिक डिपॉजिट्स ऑफ द ओशियन फ्लोर। ओशियन फ्लोर में जितना भी डिपॉजिट्स होता है उसके बारे में आज पढ़ेंगे कि ओशियन फ्लोर पे क्या क्या डिपॉजिट हो जाता है। ठीक है, तो चलिए शुरू करते हैं। मटेरियल्स इरोडेड फ्रॉम द अर्थ विच आर नॉट डिपॉजिट बाय द रिवर और एट द कॉस्ट आर इवेंचुअली ड्रॉप्ड ऑन द ओशियन फ्लोर, and the dominant process is slow sedimentation, where the eroded particles very slowly filter through the ocean water and settle upon one another in layers, and the thickness of the layer of sediment is still unknown. Its rate of accumulation is equally uncertain. Generally speaking, we may classify all the oceanic deposits as either muds, odes, or clays. The muds, these are tertigenous deposits because they are derived from the land and are mainly deposits on the continental shelf. And the muds are referred to as blue, green, or red muds. Their coloring depends upon their chemical content. Number second, ojos. These are pelagic deposits. Pelagic deposits because they are derived from the oceans. They are made of shelly and skeletal remains of marine microorganisms with calcareous or siliceous parts. Ojos have a very fine floor-like texture and either occur as accumulated deposits or float about it in suspension. Let's talk about the clays. These occurs mainly as red clay in the deeper parts of the ocean basin and are particularly abundant in the Pacific Ocean. Red clay is believed to be an accumulation of volcanic dust blow out from volcanoes during volcanic eruptions. Let's talk about the salinity of the ocean. Almost every known chemical element can be found in varying proportion in the ocean, whose most characteristic features is their salinity. In contrast to the fresh water of lakes and streams, all seawater contains large amounts of dissolved minerals, matter of which sodium chloride or common salt alone constitutes more than 77%, and the other more important compounds include magnesium, calcium, and potassium, while the rest are distinguishable only in traces of very minute quantities. Due to the free movement of the ocean water, the proportion of different salt remains remarkably constant in all ocean and even to great depth, but the degree of concentration of the salt solution in ocean does vary appreciably in different areas, and this is expressed as salinity, the degree of saltness of water. Salinity, in short, we can say that the degree of saltness of water, either as a percentage of more, often in parts per thousand variations, are shown in salinity distribution map by isolines, lines joining places having an equal degree of salinity. Generally speaking, the average salinity of the ocean is 35.2%, about 35 part of salt in 1000 parts of water. In the Baltic Sea, where there is much dilution by fresh water and melting ice, the salinity is much lower, only about 7%. In the Red Sea, where there is a much surface evaporation and fewer rivers to bring in fresh water, and the average salinity increases to 39%. In enclosed seas, which are areas of inland drainage such as Caspian Sea, the salinity is very high, 180%, and in the Dead Sea of Palestine, a salinity up to 50% has been recorded. You can imagine what the condition of the water is. And the highest salinity is perhaps that of Lake Van in Asia Minor with 330%, and it is a salt lake and salt are collected from its shores, and the density of the water is so high that in Lake Van or Dead Sea it is almost impossible to sink. Beginner swimmers will find it much easier to float here than everywhere else. The variation of salinity in the various seas and oceans is affected by the following factors, and salinity affected by the following factors. And the factor which can affect the salinity, the rate of evaporation. The water fringing the high pressure belt of the trade wind desert between 20 to 30 degree north and south have high salinity because of high rate of evaporation caused by the high temperature and low humidity. and the temperate ocean have lower salinity due to the lower temperature and a lower rate of evaporation. High temperature, low humidity. The temperate ocean have lower salinity due to the lower temperature and a lower rate of evaporation. Or we can say that the lower rate of evaporation, lower rate of salinity, and higher rate of evaporation and higher rate of salinity. The amount of fresh water added by the precipitation and streams and iceberg salinity is lower than the average 35% in equatorial waters because of heavy daily rainfall and high relative humidity. Oceans into which huge rivers like the Amazon, Congo, Ganges, Irrawaddy, and Mekong drain have much of their saltness diluted and have a lower salinity. The Baltic, Arctic, and Antarctic water have a salinity less than 32% because of the colder climate with little evaporation and because much fresh water is added from the melting of the icebergs, as well as by several large poleward bound rivers, that is Ob, Lena, Yenisei, and Mackenzie. The degree of the water mixing by currents in wholly or partially enclosed sea such as Caspian Sea, Mediterranean Sea, Red Sea, and Persian Gulf. The water don't mix freely with ocean water and they are not penetrated by ocean currents. Salinity is high, often over 30%. In areas of inland drainage without link with ocean, continuous evaporation under an almost cloudless sky causes the accumulation of salt around the shores. In the open ocean where currents freely flow, salinity tends to near the average 35% or even a hitter lower. And the range of salinity is negligible where there is free mixing of water by surface and subsurface currents. Temperature of ocean water. Like land masses, ocean water varies in temperature from place to place, both at the surface and at the great depth. Since water warms up and cools down much more slowly than the land, and the annual range of temperature in any parts of the ocean is very much smaller. It is less than 10 degree Fahrenheit for most of the open seas. Generally, the mean annual temperature of the surface ocean water decreases from about 70 degree Fahrenheit in equatorial areas to 55 degree Fahrenheit at latitude of 45 degree north and south, and drops almost to the freezing point at the poles. And the reduction of the temperature with latitude is, however, never constant because of the interference by warm and cold currents, winds, and air masses. Unlike the solid earth, ocean water is mobile and variation is temperature between different parts of the ocean can be expected. Water flowing out from the Arctic and Antarctic as a cold current, and such as Labrador and current of northeast Canada, tends to reduce the surface water temperature. Port of eastern Canada, even at 45 degree north, are thus ice bound for almost half of the year. In the same way, coasts bound by warm current, such as North Atlantic drift, have their surface temperature raised, and the Norwegian coast, even at the latitude 60 degree to 70 degree north, is ice free throughout the year. And the highest water temperature are found in enclosed seas in the tropics, that is the Red Sea, which are recorded at temperature of 45 degree to 100 degree Fahrenheit. The Arctic and the Antarctic waters are so cold that their surface is permanently frozen as pack ice down to the depth of several feet. In the warmer summer, parts of the iceberg off as iceberg that both dilute the water and lower the surface temperature in surrounding ice free seas. The temperature of the ocean also varies vertically with increasing depth. It decreases rapidly for the first 200 fathoms at the rate of 1 degree Fahrenheit for every 10 fathoms, and then more slowly until a depth of 50 fathoms is reached. Beyond this, the drop is scarcely noticeable, less than 1 degree Fahrenheit for every 100 fathoms. In the ocean deeps below 2000 fathoms or 12,000 feet, the water is uniformly cold, just a little above freezing point. It is interesting to note that even in deepest ocean trenches, more than 6 miles below the surface, the water never freezes. It is estimated that over 80% of all ocean water have a temperature between 35 degree to 40 degree Fahrenheit. And this is done for the today. We will talk about the movement of the ocean current tomorrow, and this is the most important topic. So let's get ready for this topic, and till then, thank you so much. Keep watching my videos.